today let us get that cord out of our way. Today, let's review for exam 3. Okay, so exam 3 will be this week, Thursday for us this summer, and that's going to be chapters 6 and 7. For the most part, I'm pretty comfortable. We've got security under control. There's a few things occurring that I'm concerned about, but I'll address those with you, those of you that need it. In general, it looks like you guys are doing okay. You're doing what appears to be your own work. Continue doing that. If you have questions, if you have concerns, let me know, but it's going to be on. We'll continue this summer. We'll continue this online, which means there will be timed questions. Those will be anywhere from 7, I guess 6, let's say 6 to 8 points each, depending on what I'm asking. And basically what I'm timing you here, what I'm testing you on in the timed questions is, can you set the problems up quickly? Can you identify the correct version of the fundamental expressions needed to solve the problems quickly? So that might be, what is the correct version of the second law that you would use? What is the correct version of the first law that you would use? Are there any other expressions you would need to solve the problem? Most of those are going to be multiple choice. Some might be true or false. There might be a short answer or two. I might set it up as an essay question where you can enter some text, and you just would describe what you would use, or the equations you would use, or how you would go about solving the problem. There might be a few of those, but most of them are going to be multiple choice. Again, identify the correct simplified version of the equation and choose it from a list, and do it quickly, right? So that should be, when you're setting one of these problems up, and go ahead, what I would do with these problems is, when you get the question, because you're going to have to generate the entire solution later, when you get the question, go ahead and start solving that problem, right? And what you might do is just be in the habit of writing correct version of the first law equation and correct version of the second law equation to solve the problem. If it's a chapter 7 type problem. If it's a chapter 6 type problem, you might just look at the timed questions, see what they're asking. But for the most part, if you just go through your process of setting up the problem as you normally would, and you're probably going to answer what I'm asking you to answer in the timed questions. Okay, so anyway, that's my goal of those timed questions, is can you set the problem up correctly? And I'll give you about half of the points I normally would on a regular face-to-face test for setting it up correctly. If you don't get it correct on the timed questions, you can still get the better part of half of those points that you would normally get for setting the problem up correctly when you actually set it up for your solution. So there'll be 4 timed questions, and then there'll be a questions portion, which will be worth basically 70 points, right? So this will be 30 points total for the timed questions. The timed questions will be worth 30 points total. The remaining 70 points will be here. It might shift a little bit. It might be 32 and 68, or there might be a 1 or 2 point shift, but roughly it's going to be about 30 points on the timed questions. Roughly 70 points then on where you submit a PDF of your solutions. And again, I'll provide detailed instructions as you've seen before. I try to make sure everything is in writing. I'll get you the detailed instructions before you actually take the exam. But again, you'll have a time limit Once you start one of the timed questions, you'll have probably 2 hours to answer all the timed questions, generate solutions to the entire question, scan it to a PDF, and submit it within the time frame specified, or you'll lose some points. Okay? If you have any questions, please let me know. Send me an email, leave a comment on this video. I noticed some of you guys have left some comments. I'm a little slow sometimes on answering those. I apologize. I don't always get a notification that a comment's been left, so I'll try to look at my settings and see if I can get that turned up a little bit better. But at any rate, at this point, I'm hoping you guys have a pretty good idea how to contact me. A lot of times, email is the fastest, most direct way, but there's several ways to get in touch with me as well. Okay, what else? I mean, I think this is logistically, my goal is for it to look much like Exam 2 and Exam 1 has. It should look very close to Exam 2. So if you will set up, how do you study for this? We'll go through Chapter 6 and 7 problems, set them up, get them to a point where all you have to do is look up properties or eliminate additional unknowns, and then run it through a calculator. When you get to that point, you should be able to answer the timed questions. That's the whole goal there. Okay? So go through the Chapter 6 and 7 problems that I didn't assign, or especially the ones that I've assigned, or the ones I've worked in the videos as examples. Make sure you can set those up and answer questions like what you would see in the timed questions very quickly, within just a few minutes. And then make sure you can work 3 or 4 problems to a solution within 2 hours or so. Okay? Practice, 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 practice. That's the best I can tell you. A lot of what we're testing on here is just solving problems. That's a skill that just takes practice. Okay? All right, what else? We can talk about topics. The topics that you would see. We can go through kind of a skeleton outline of the topics we would see here. If we look at Chapter 6, what we have as Chapter 6 in the Chamberlain-Bowles text, it's basically an introduction to the second law and a little bit of background as to how the second law was derived. And so the second law was formed from 2 main ideas, and these are what we typically call the Kelvin-Planck statement and the Clausius statement. All right, to give credit to those that were basically kind of the forefathers, if you will, of the second law in its current form. One of those statements is a device, and I'm paraphrasing here, a device in a cycle cannot produce net work by exchanging heat with a single body. And I believe this is the Clausius statement, but this could be the Kelvin-Planck statement. I don't have that memorized. A device operating a cycle cannot produce net work by exchanging heat with a single body. You have to be doing something else. You will eventually exhaust the single body of heat, and or you will eventually blow the system up. Okay? And so the other implication here is I cannot take heat from a single body and turn all of that heat into work. I have to reject the remaining heat that I couldn't convert into work to another supply. So that could be the other thing that I'm doing. I could be rejecting heat to a second body. Right? That's quite possible. But I cannot have a device operating in a cycle repeatably with only a single heat reservoir. I'm going to have to absorb heat from one and reject heat to a second one. The second statement that derives the second law or forms the basis of the second law is, again, referring to a cyclic device. A device operating in a cycle cannot simply transfer heat to a higher temperature body from a lower temperature body. That can't be the only thing it does. Now, we have devices that do this. You might hear some background noise. My air conditioning unit is running right now. That's a device that moves heat from a lower temperature body to a higher temperature body. My air conditioner right now is taking, it's because it's the summertime, it's taking heat from inside my house and pushing it outside my house. But that can't be the only thing it does. What it's also doing is it's using electricity to run a compressor unit to increase the energy of the fluid stream to a point, so to a high enough temperature point that it will actually move heat into the higher temperature body. And then it goes through a process where that refrigerant gets cold and it'll absorb heat from the lower temperature body, and then it's ready to repeat in the cycle. Okay? Now, maybe you could do it a little bit, not in a cycle, but that's not the purpose here. Our goal, just make sure I'm still on the screen there. Our goal here is to have this heat, or have these devices operating in a steady flow fashion. The only way you're going to get them to operate in a steady flow for any period of time is to have a cycle around them. Right? That's what we see when we talk about these devices that we'll talk about in just a little bit. Okay? Now, along those lines, so if we kind of some of the theory that's associated with Chapter 6 here, some of that theory is the idea of a perpetual motion machine. The idea of a perpetual motion machine is a device that could just operate on its own indefinitely, perpetually, with no outside influence. Now, the problem with that is for that to happen, it's either going to have to violate the first law or the second law. Right? So for a device to operate perpetually with no outside influence, it's going to be in violation of one of these two statements, or it's going to have to generate its own energy to continue operating. Okay? It's going to have to create energy, or it's going to have to violate the direction that we know and understand energy can flow. Right? So again, the first law basically just says you can't create or destroy energy. What you have is what you have. It's a fixed amount. Unless we get into converting mass into energy in a nuclear reaction, that's another story. Assuming that's not happening, then the energy we have is the energy we have. And the second law then has some dictation about, some specification about what direction that energy can flow and what you can and can't do with that energy that we have. Okay? So the perpetual motion machine is a device that violates one of those concepts in some fashion. Now, the reason that we can't have, or one of the main reasons we can't have perpetual motion machines is irreversibilities. I think I'm spelling this right. I apologize if I'm not. The idea of irreversibilities. What are those? These prevent both our system and the surroundings from reaching their initial states. And that's my alarm. We'll have to pick up there on the next video.